Hey everybody, Mr. Dannahower here. In this lab, we're going to be investigating how acid rain affects different lakes, primarily based on the bedrock that is in those lakes. And of course, acid rain, we've learned, is caused by multiple sources: sulfur dioxide, which is released when we burn coal, and different nitrogen oxide compounds that are often released whenever we burn fuel, like in combustion engines for cars. And so in this lab, there's a few chemicals we're going to be working with. One of them is called universal indicator, and it's this green color. And basically, universal indicator is a mixture of different chemicals that change colors depending on the pH of the solution that we put the universal indicator into. So for part one of our lab, we need to make some observations of what colors do different acids and bases change the universal indicator. And so I'm going to start with just plain old distilled water and put a few drops here. Now we'll add a few drops of the universal indicator and see what color we get. So you can see in a neutral solution, which water is neutral. This is distilled water, so it should be neutral. It's neither acidic nor basic. It's 7 on the pH scale. So universal indicator is going to indicate green. Now let's go ahead and test some hydrochloric acid and see what color the universal indicator changes. So I put a little puddle of hydrochloric acid here and add my universal indicator. And we're going to see immediately this is going to change to a red color. So when universal indicator is put into an acidic solution, it's going to change red, or it could change yellow and orange. So that means that it is less than 7 on the pH scale. Usually red for this universal indicator is a 1 or 2 on the pH scale, so that's very acidic. A 3 or a 4 would indicate an orangish color, and a 5 or a 6, less acidic, would be a yellowish color. Okay. Now let's go ahead and try a little bit of our ammonia here and see what color that changes the universal indicator. So we added our ammonia, common substance that we have in a lot of different things. As soon as we put that in, the universal indicator, we see that it is kind of a bluish color. Okay, so when universal indicator is put into a basic solution or a pH higher than 7, then we're going to see blues and purples for our color changes. So take a second and jot some notes down about our acids changing to warmer colors, or lower pHs changing the universal indicator orange. Neutral is going to be greens, and our basics are going to indicate those cooler colors, greens and blues. Now for the actual lab that we're going to do, you'll notice I'm using a Petri dish here, and it has 2 pieces, a lid, which is a little smaller, and then a base. And we'll come back to the base in a minute. I'm going to start off by putting a line of universal indicator drops, just tiny drops here, along the lid, and these are going to simulate our clouds. There we go. I might come back and get a few more of those here. Those bubbles are really messing with it. All right, so we can see those are green because they're neutral. And now let's go ahead and set up our different lakes. So I've drawn a little schematic here, and I have a place to put my factory in the middle, and a place for my mountain lake water, Horsetooth Reservoir water, and Plains Lake water. So we'll start by putting 5 or 6 drops of each one of these. I want to try to keep it consistent because that's always important in science, that we keep things consistent, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We do about 10 drops is about right. Now for our mountain lake here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pretty close. And let's go ahead and get our Plains Lake. This would be maybe water from somewhere out on the plains. Lakes in Nebraska. 5, 6, 7, 8, 9, 10 looks about right. Okay. So one thing to note, just as a reminder that you should have read about in the background information, plains lakes often have a limestone base because of the geology of the region that we live in here, whereas a mountain lake is more likely to have bedrock that is made of igneous type rocks like granite or metamorphic gneiss. And that's going to have a major impact, we're going to see in a second, on how things work here. Okay, I'm going to add 2 drops of universal indicator to each lake. Okay. We're going to notice that they're neutral. And we'll do a little stirring there. Get a clean toothpick. I want to make sure we're not mixing the different ends of the toothpicks. There we go. Okay. All right, I might not have gotten enough in the mountain lake. Let me just get a little more. The color's different. Okay. Now I'm going to go ahead and add the chemicals that are going to simulate our factory or car exhaust, those chemicals that are going to create acidic rain. Okay. And for that, I'm going to use a little bit of sulfuric acid. That should ring a bell because we've talked about sulfur dioxide converting to sulfuric acid. So I'm going to put a couple of drops of that in our factory. And then I'm going to put in some nitrate compounds, some sodium nitrite, actually, which is NaNO2. And as soon as I put these together, I'm going to put the lid on, and then we need to watch what happens here. Okay, here we go. Lid's upside down, and let's make some observations. Right away, we're starting to see some changes, right? We're starting to see these clouds are already turning an orangish color. Also, look at the edges of my mountain lake here. The edges of my mountain lake are already beginning to turn an orangish color. And we'll let the simulation run for a minute here. Okay, very orange on these clouds with a little bit of green in the middle. The mountain lake is continuing to turn an orangish color. Starting to see a little yellow there too. If you look at Horsetooth Reservoir, we've got a tiny bit of orangish, yellowish on the outside edges, maybe a little bit on the Plains Lake too. Okay, just keep running this. So as that factory is giving off more and more of those chemicals, right, those chemical compounds that are getting into the water and creating an acidic solution, we're seeing these changes take place. All right, this is about as acidic as our clouds are going to get. So remember that orangish color is indicating probably a 3 to 4 on the pH scale. So it's not the most acidic like red, but it's pretty acidic. And we're seeing the mountain lake has almost completely changed to acidic now. Horsetooth, again, we're seeing that ring around the edge, and it's pretty orange, and a smaller ring around the Plains Lake. After another 30 seconds here, again, our mountain lake is very acidic. Well, it's as acidic as the clouds are, right? It's completely changed all throughout. Our Horsetooth Reservoir is getting pretty close to that. There's a little bit of neutral still in the middle where it hasn't penetrated all the way through to the center. And again, our Plains Lake is still neutral in the middle with a little bit of acidic water on the edges here. So we're going to wait another 30 seconds and we'll wrap this up. Okay. Well, I'm going to go ahead and take the lid off of here. We can see those clouds have changed all throughout, and we'll set that aside. And if we just kind of re-look at our lakes here, that doesn't make sense. Okay. Again, mountain lake completely acidified. Horsetooth, pretty much all the way, right? There's just a tiny bit of green in there. And then the Eastern Plains Lake is not quite as orange. It's kind of a yellowish color, so it's not quite as acidic. And we still see a good chunk of green where it hasn't changed that lake in general all the way through. So if we compare these three, here are some questions you need to be answering in just a minute. First of all, why did all of these lakes change, right? Why did the clouds change to become acidic? Why did the mountain or all three of the lakes change and become more acidic? The second question we want to do is really compare. That's our question for this whole lab. How does acid rain affect different lakes differently? And then why is that? And so in your background information, as you've read through that, you should be able to pull out the main reason why a mountain lake would change much more quickly and become more acidic or be more affected by acid rain than a plains lake or Horsetooth Reservoir. That's all for the demonstration here. Now you can go ahead and answer those questions, and I hoped that you learned a little bit more about how acid rain affects different lakes.